Good morning. Hi. Happy Tuesday. It's one of the happiest days of the week. Probably. No bow tie. Dang it. All right. All right. I have to use this as my mirror. Thanks. Does that make sense, Emily? Looks kind of rough. Okay, cool. Wait, Emily, did you log on to here to get a hold of me? Or were you just like in case I didn't answer your email? This is really rough. Maybe. It's something. Okay. Best I can do given the circumstances. I forgot because I had just taken a shower and changed. I forgot I needed to go for the bow tie. I'm sorry, Abby. I'm sorry. My bad. I'm losing focus in these last weeks. Okay. All right, let's do this. So, we talked about 3x3 determinants yesterday, which also used 2x2 determinants. So let's do our warm-up, which is just more practicing of finding that determinant. So the determinant of P, that's what these bars mean. So we have our little formula, our pattern, which is start here. So 2. And we imagine if we get rid of that row and column, so these 4, -1, -1, 2, 1. And then minus, even though this is a positive 1, the formula just has a minus here. And then imagine we get rid of that row and that column. So 1, -1, 1, 1. It's these 4 numbers. And then plus 1, 1, -1, 1, 2, if we cross these out. 1, -1, 1, 2. Wait, Emily, are you still here? Probably not. Probably left. Can you take a PFA right now? For these, now each of these is a 2x2 determinant. Right, so remember for 2x2 determinant, it's main diagonal multiply. So -1 times 1 is -1 minus 2 times -1, so plus 2, minus 1. 1 times 1 is 1, minus 1 times -1 is -1. So minus -1 would be plus 1. 1 times 2 is 2, minus 1 times -1 is -1, so 2 plus 1. And then it's just simplifying. 2 times 1, 1 times 2, plus 1 times 3. So 2 minus 2 plus 3, which is just 3. Yeah, okay, yeah, hold on. Let me pull it up. All right, it's good. Okay. Now, also remember what this means. Whoa. Right? If the determinant is 3, so specifically the determinant is not 0, which means that this is not singular. Which means that our original matrix P does have an inverse. Okay, it's a relationship between these three properties of determinant is not 0, that means it is not singular, which means it does have an inverse. Right? Or if the determinant were 0, okay, determinant is 0, that means this is singular, which means that it does not have an inverse. Okay, so kind of have to think about those relationships. Okay. Cramer's rule. This is our last thing that we're going to learn. Wow. It's a way of solving 3x3 systems. So 3x3 means 3 variables, x, y, z, and 3 equations. All right. And so far we have a couple different ways we've talked about. We can do just solving it by hand using substitution and elimination. And we can do Gauss-Jordan elimination, which we practiced. And thirdly, we could do Cramer's rule. I specifically like Cramer's rule the best, actually. It's still, you know, kind of some annoying work, but I still think it's better than the other two. Okay. And what's nice about Cramer's rule is we can just solve for one specific thing. Like we could just solve for y or just solve for x or z without finding the others. Okay, so now what the hell do these things mean? Okay, so first off, this just capital D here is just the determinant of the matrix. Right, it'll be like we just did what we did in the warm-up. Okay, but Francois, like, what is dx or dy or dz? It is the matrix, or this, so dx specifically is the matrix that the x column is replaced with, let's see, what's a good thing to call it? We'll just say with the right side of the equations. And again, I'm sure that makes no sense whatsoever, but once I show you, I think it'll help. Okay, Okay, so D is just the determinant. So all of these just have this capital D, right, in the denominator. But this dx and dy and dz, so this is either, so this one will replace the x column, on this one will replace the y column, on this one will replace the z column. Okay, so let me show you what that looks like. All right, use Cramer's rule to solve the system. Okay, so the first thing we would want to do is find this capital D. Now, what is that? That is the determinant of this matrix, because these are just the coefficients, right? 2, 1, 1, 2, 1, 1. 1, negative 1, negative 1. 1, negative 1, negative 1. 1, 2, 1. 1, 2, 1. All right, that's all it is. Now, luckily, to make this easier for us, so that we don't have to just keep doing these over and over again, this is actually exactly what our warm-up problem was. Right? This is exactly the equation P, right? It's that matrix. So we already know that the determinant is 3. Right, now that won't normally happen. We won't start by knowing this determinant, so we'll have to find it, but just to save us some time. So we already solved, we know that capital D is 3. Okay, so now let's go through and let's find dx. So notice I kept these two columns the same. 1, negative 1, 2, 1, negative 1, 1. That's exactly the same thing that I have here. Okay, but what I'm going to do is I'm going to replace, instead of the x column, right, because in these matrices, if I look at the equations, right, this is the x column, 2, 1, 1, 2, 1, 1. So I'm going to replace that with the stuff that is on the right side of the equation. So 3, 0, 0. I'm going to replace that. All right, so that's what we mean when we say this dx. All right, and now it's just calculating determinant. We can do that. All right, so that's just using our formula for determinant, right? Doing the thing where we cross out, imagine you get rid of the row and the column, what 4 numbers are left, that's what goes inside of those 2 by 2 determinants. Please don't forget that this is a minus sign, even though this is a positive 1, right? That's true, that is a positive 1, but we put a minus sign in front of it in the middle here. All right, it's just part of the formula. Okay, now let's do some 2 by 2 determinants. So this would be negative 1 plus 2, so 1. Minus 1, 0, minus 0, okay, 0. Plus 1, 0, minus 0, also 0. So this just equals 3. So I'm going quickly through these determinants, right? Like these 2 by 2 determinants. So for this, this, and this, I'm going pretty quick through that. So if you're confused about how I'm doing that, I mean, I'm just using the 2 by 2 formula, but if you're confused about it, just let me know and I'll write it out more specifically. That's fine. Okay, so this is not the answer, but I can use it to find the answer. So Cramer's rule tells me that the value of x is equal to dx divided by d. Basic formula, yeah, for sure. It's this. So A times D is that main diagonal, and then minus B times C. All right, so that's 2 by 2 determinant. Okay, so x dx, so dx is 3. Oops. All right, we just found dx is 3. D from our original determinant, or from the warm-up, is also 3. So x is 3 divided by 3, which I think is 1. All right, so that's solving for x. Now let's solve for y. So I need to know what is dy. So now, since I'm doing dy, I'm going to keep the x column the same and the z column the same. So 2, 1, 1, 1, negative 1, 1. But now I'm going to change the y column. Since we're doing dy, I'm going to replace the y column with this, that same thing that I replaced, but for the x column up here, 3, 0, 0, because that's the stuff that's on the right side of the equation. So 3, 0, 0. And now we do our formula. So 2, 0, negative 1, 0, 1, minus 3, 1, negative 1, 1, 1, plus 1, 1, 0, 1, 0. Again, I'll keep saying it. Minus sign in here, even though this is a positive 3, but the formula puts a minus sign there. It's the only spot it does that. Okay, so this is 2. 0 minus 0 is 0. 1 minus negative 1, so 2. 0 minus 0, 0. So dy is negative 6. Cramer's rule tells us that the y value is the same thing as dy divided by d. We just figured out that dy is negative 6. Capital D is 3, right? That's from all the way up here. That's still the same value for the denominator. So negative 6 over 3. So y is negative 2. Okay, so finally I want to solve for z, so I need dz. What that means is my x and y column are going to stay the same from what they were originally. So that's the x and y column I'm now going to keep the same, but the z column is what I will replace with the 3, 0, 0, since we're doing dz. go through the formula. I'll keep saying it as a negative 1 there, even though this is a positive 1. The minus sign is part of the formula. And now we just do all these 2 by 2 determinants. 0, minus 0, 0. 0, minus 0, 0. 2 minus negative 1. So positive 3. 0 minus 0 plus 9 is 9. So then to actually solve for z, we would do dz over d. So 9 over 3, which is 3. So the final answer to the problem, since I've now solved for x, y, and z, is 1, negative 2, positive 3. So Cramer's rule is very easy if you know the formula. If you can do 3 by 3 determinants really well, then Cramer's rule is astoundingly easy. Right? But that means you have to know the formula for 3 by 3, and you have to be comfortable with it, and you have to know and be comfortable with the 2 by 2 determinant formula. Okay, but if you have those down and you're not messing up little negative signs and stuff like that, then this should be cake. Right? But it is hard. It's not hard. It's easy to mess up. Trust me, I've done it plenty. Okay, so I think I said this before, but like 9 times out of 10, if people ask me about, hey, I'm really struggling with the AFA and like Cramer's rule, and I say, okay, show me your work. Let me see what you've done. Almost every time they know the formulas, but just like mess up a negative sign somewhere. Especially doing those 2 by 2 determinants, like doing this determinant of 1 times 2 is 2 minus 1 times negative 1, so that's minus negative 1, so that's actually plus 1, which is why we have this positive 3 here. It's so easy to just slightly slip up on one of those and it screws up your entire value. All right, but there's that. So let's do one smaller example. Can you do this with larger matrices? Yes. But here, let me show you what it does. Let me do. Okay, so let's say I have a 4 by 4 determinant, right? So we would do our same thing. Start up here. So there'd be 1. And then get rid of that row, get rid of that column. So then 6, 7, 8, 10, 11, 12, 14, 15, 16. And then minus 2. Get rid of that row and column. So 5, 7, 8, 9, 11, 12, 13, 15, 16, plus 3. I'm not going to go through and do this whole thing. Don't worry. This won't be that painful. 5, 6, 8, 9, 10, 12, 13, 14, 16, minus 4. So this is something new. So actually what the formula that we've done for 3 by 3 is there's always a minus sign right here. technically what it is it just alternates, so it goes positive, plus sign, plus sign, minus sign, if you have larger matrices. And then 5, 6, 7, 8. Can you guys see that? Barely. Or not 8, sorry. Just 5, 6, 7. 9, 10, 11, 13, 14, 15. Okay, so it's basically kind of that same process, but now look here. Now we have a problem where there's 4. These are all 3 by 3 determinants. So now for each one of these, we would have to go through and do the 3 by 3 determinant process. Right, so this would turn into, 1, and then 6, 11, 12, 15, 16, minus 7, 10, 12, 14, 16, plus 8, 10, 11, 14, 15. Right? And so this is all, yeah, exactly. This whole thing is just for this one term. But then we'd have one of these for each, the second term, the third term, and the fourth term. Yeah, it's a lot of work, but it does work though. And so you could do this with, up to like any number matrix, like a 10 by 10 matrix or a 12 by 12 matrix. The problem is each time you go up a size, the amount of work grows like exponentially. Because now you have to, whenever you find the determinant of a matrix, you then have to find the determinant of the matrices that are smaller than that. And then maybe you'll have to go, like if we went up to a 5 by 5, then we would have a row of 4 by 4 matrices. And for each 4 by 4, you'd have to do a 3 by 3 matrix and a 2 by 2 matrix, like all the way down. Have a stream of you solving a 10 by 10 matrix, the determinant. That would be wild. I think the largest I ever did by hand was a 5 by 5 maybe. No, I think 4 by 4. I think the largest I've ever done by hand is like one of these problems. I know I've solved larger ones that I just used, some sort of like computer software or calculator, but actually doing it by hand, I think the largest I've done is 4 by 4. I wonder how long it would take, genuinely, to do a 10 by 10. Should that just be the final exam? The final exam is one question. Find the determinant of this 10 by 10 matrix. I think that would be pretty good. Send it out. Hey guys, final's just one question. It's just determinants, no problem. That could be fun. Yeah, so the general rule is you do this process of crossing out the row and the column, and then the alternating signs, positive, negative, however long it goes. And then the problem is it just creates a lot of work. It's already like a decent amount of work for, it's not bad. Like 3 by 3 matrix determinant is this, which isn't horrific. It helps that there's some zeros here, but it might be like another line or two of work. But even just going up from 3 by 3 to 4 by 4 already, increases the amount of work you have to do like tenfold. And then doing 5 by 5 or something, that's crazy. That would be an interesting test. That's true. Huh. I remember doing a 4 by 4 by hand, but I didn't get the right answer. I knew what answer I was supposed to get, and I didn't get it. And so I remember like spending like a couple hours like going through and trying to figure out where I went wrong. And like I think I did it again and still like didn't quite have the right answer, and like there's so many calculations that go on inside of these. It's like, so dumb. There's so many spots where you can just slip up a tiny amount. Man, college sure was fun. All right. Okay, so let's we won't do the full problem again. But let's say use Cramer's rule to solve for y. Okay, so again, that's one of the good things about Cramer's rule is it allows us to just solve for a specific thing. If you solve a system by hand, just like doing substitution or elimination, or if you do Gauss-Jordan elimination, you pretty much have to find everything, right? You have to find x, y, and z. Cramer rule is good because we can just ignore whatever we don't want to find. So if I want to find y, well, great. I know that y is dy over d. It doesn't have anything to do with finding what x is or what y is. Okay, so first thing, let's find the determinant. So that would be 2, 1, 1, 1, negative 1, 4, 1, 2, negative 2. Okay, so that's just looking at these coefficients, 2, 1, 1, 1, negative 1, 4, 1, 2, negative 2. And we'll do the determinant. Oops. See? Simple error. Okay, now do the 2 by 2 determinants. So positive 2 minus 8, so negative 6. Negative 2 minus 4, so again, negative 6. 2 minus negative 1, so 3. Negative 12 minus 6 plus 3. No, plus 6. Aha, see? Whew. Close. Negative 1 times negative 6, so plus 6. So this determinant would be negative 3. Okay, now we want to know dy. That means we will keep the x column and the z column exactly the same. However, we will instead, since we're doing it for dy, instead of the y column that we had originally, we will replace it with the stuff that's on the right side of the equation. So 1, 0, 3. And now we'll do this determinant. The good news is it doesn't take long after doing a few of these to really start to drill home that 3 by 3 determinant formula. I feel like it gets kind of stuck in your head because that repetition of the pattern of how you do it, hopefully at least. Okay, so these 2 by 2 determinants, this would be 0 minus 12, so negative 12. Minus 1, negative 2 minus 4, negative 6. And then 3 minus 0, so 3. Negative 24 plus 6 plus 3. which would equal negative 15. All right, so to solve for y, that's dy over d. So negative 15 over negative 3. So that means that y is positive 5. Ta-da! Who cares what x is? Who cares what z is? It just asks us for y. And that's that. Yeah. I don't know, depending on how you feel about this or how much you like this, I can stream tomorrow and do a couple more of these practices, or at least another, at least a warm-up problem of this if you wanted to just see more of it. Or if you feel good, then that'll just be the last lesson that I stream. On the test, will you ask us to use a specific system to solve a matrix? Now, when you say system, do you mean like method, like a specific method? If it were on there, then yeah, it would either say specifically like use elimination, or use Gauss-Jordan elimination, or use Cramer's rule. I would state specifically, probably. But even if I did, these problems are pretty tedious, so it would be like on the most recent performance task on the system that I had you guys solve, it was pretty cheese, right? Like it only took a few steps. It wasn't super intense. Like there was a lot of variables missing, so that was easier to solve by hand. It would be a similar thing. Like if I gave you a Gauss-Jordan elimination, it would be very few steps to actually finish it off solving. Or if I gave you a Cramer's rule, it would probably be like solve for y or solve for z. I would just ask like a specific thing. So if I gave you a question about solving systems, yeah, I would tell you a specific method, but it won't be pages and pages of work. Right? Except Abby's. The one I'm going to send Abby is going to be a 10 by 10. Yeah, reminder for the final exam, I'm finishing it up. I was working on it right before this class started. I'm finishing it up now, hopefully by the end of the day, and I'll send that out. So reminders, it's worth 15% of your grade overall. Like I said yesterday, that sounds like a lot. It sounds really intense, but as long as you get like a somewhat decent score on it, it's really not going to bump you down. I mean, if you're hanging on to a B by 1%, or you're right at an 80 or something, like, okay, yeah, you need to make sure you do well. But if you're in the middle of a grade, like an 85, well then, unless you really blow that out of the park and get like 100% or 0%, then it's not gonna do a ton. All right, try not to freak out too hard. And I'll just send it to me by the last day of school, which is next Friday. Not this Friday, next Friday. But, use your notes, use, whatever. Yeah, Preston, go for it. Okay, so it should be out to you in the next few hours. I don't know, depending on how it goes, or depending on if I have to end up going to some meetings or something. Maybe tonight, maybe even tomorrow morning, but sometime soon for sure. Also, yeah. Okay. All right. So yeah, I mean, today is our last lesson. I might still log on to stream if like there's this particular PFA that lots of people are struggling with. I might get on and do like a review day of that particular PFA. Maybe I'll just log on and play some random games like people have asked or something. Who knows? Kahoot. We could do some Kahoot. I don't know. I mean, it depends. I mean, there's already a limited amount of people that actually watch this live, anyways. And so, especially, I don't know if people are going to be really tuning in randomly to see if I'll actually have something that's not even related to school. But maybe. Who knows? I'll let you guys know ahead of time if I plan on doing something like a Kahoot or like math related. Okay. Any questions about, I don't know, school, this class, finals, grades, nerds? No? Okay. Well then, that's that. Look for my message that I send out about the final. And otherwise, might randomly be on stream sometimes doing who knows what. So if you're super bored, maybe check to see sometime, but no promises. And good luck. Let me know if you have any questions or need help with something. I'd be glad to do that. And I'll see you guys when I see you. Peace.